Hello and welcome back to College Algebra, MAT 150. In this lecture we will be discussing basic operations with complex numbers. So just like real numbers, or integers, we can add, subtract, multiply, and divide. And we won't be discussing dividing too much. However, we can talk about the basic ones, adding, subtracting, and multiplying, relatively easy. So 4 plus I minus 2 minus 3I. So why would we say it like this? Well, again, this is one complex number minus another complex number, because that's how you write complex numbers, the real number plus or minus the imaginary part. Same thing, minus real plus or minus the imaginary part. So how do we deal with it? Well, it's just like dealing with any other algebraic expression. You can treat the I almost like a variable. So we just drop the parentheses. We have this minus, so we're going to have to distribute the negative, so that becomes minus 2 plus 3i. And then we combine like terms. 4 minus 2 is 2. And then I plus 3i is plus 4i. And we took two complex numbers and we subtracted them, and what we got was also a complex number. 2 plus 3i is one complex number. 4 plus 5i is another. And notice here, this is one number times another. You can multiply them. And again, just like with variables, you can just sort of FOIL this out. So it's two binomials sort of looking things. So outer first term, outers, inners, second term with second term. So 2 and 4 is 8. 2 times 5i is 10i. 3i times 4 is 12i. 3i plus 5i is 15i squared. And then further, we can continue simplifying. 8 and then 10i and 12i is 22i. But this is where things sort of start to change. So far that one looked normal, like we're dealing with an algebraic expression. So this one, however, the moment you have a squared next to your I, remember, I squared is the same thing as -1. So, and you can break down power, you can basically break down every power of I to be either plus or minus 1 or plus or minus I. And I squared happens to be equal to -1. So this is 8 minus 15 plus 22i. So positive 15 times -1 is the minus 15. And 8 minus 15 is -7. And we took two complex numbers and we multiplied them out, and we got a complex number out. Similarly, we can take this thing, 1 minus 7i squared. Remember, you can't sort of just distribute the square over addition. Okay, so, or addition or subtraction. So what you have to do is you have to write it out. So go back to the definition of what it means to be squared. It means two copies being multiplied by each other. And just like before, we're going to kind of FOIL it out. 1 times 1 is 1. 1 times -7i is -7i. The -7i times 1 is also -7i. -7i times -7i is plus 49i squared. Again, simplify. The middle terms become -14i. The I squared becomes -1. So positive 49 times -1 is -49. Again, I'm just replacing the -1 here. Replacing the I squared with the -1 and just putting it out in front. And then 1 minus 49 is -48. And then minus 14i. So -48 minus 14i is our new complex number after squaring this complex number. So this last one, we have the root of -4 times the root of -9. A lot of times people will want to multiply this together. And in the last lecture, in 3.1 part 1, we made a mention that the root of a times b is equal to the root of a times the root of b when at least one of them isn't negative. So if they were two separate, we could normally multiply them together if at least one of them was positive. But in this case, both of them are negative, so we can't do that. But what we can do is remember that the root of negative 1 is equal to I. And what we can do is we can use this idea but in a different way. So negative 4 is the same as 4 times negative 1. And the root of negative 9 is the same as 9 times negative 1. And what we can do is we can basically get rid of the negative 1 by pulling it out to be I. So this is the same as the root of 4, the root of negative 1. And then the root of 9, the root of negative 1. Again, we can separate these because at least one of them is positive. If both of them are negative, then we couldn't do this. So I couldn't go from this step to this step if both of them, if 4 was still negative and that was also a negative 1. But what's the root of 4? Well, that's 2. What's the root of negative 1? That's I. What's the root of 9? That's 3. What's the root of negative 1? Again, that's I. And what is 2i times 3i? Well, that's just 6i squared. Again, what is I squared? That's the same as negative 1. And then 6 times negative 1 is negative 6. That concludes this lecture.